All right, this video is for learning target 3. We're going to do it kind of quickly. I'm recording this not during the class period, so if you need to pause it and rewind, feel free to do so. But we're graphing exponentials. Yesterday we talked about inverses, and an exponential will be the inverse of a logarithm in target 4, and we'll use that relationship in the graphing we learned today to help us graph logarithms in target 5. So target 3 video goes really well with target 5. If you're watching back and reviewing, I would watch them back to back. But anyways, here we go. We will rarely use technology, mostly mental math. So in number 1, when you're graphing 3 to the x, start by finding ordered pairs to graph. So plug in 3 to the negative 4, 3 to the negative 3, 3 to the negative 2, etc. And I'll start with 3 to the 0, because anything to the 0 is 1. 3 to the 1 will be 3, etc., etc. So we can kind of do mental math, and you get 1 there, 3 there. 3 to the 2, 3 squared would be 9. 3 cubed, 27. 3 to the 4th, 81. Then we kind of go backwards and do 3 to the negative 1, which, if you'll remember, a negative exponent takes what it's attached to the denominator, so 1 over 3, and makes that exponent now positive. So 1 over 3 to the 1, 1 over 3. With a negative 2 exponent, it would not only flip the 3 into the denominator, it would also square the 3. So 1 over 3 squared, 1 over 9. And you could probably notice the pattern here with the 1 over 3, 1 over 9, 1 over 3 cubed, so 1 over 27, and then 1 over 3 to the 4th, 1 over 81. The same numbers we just found with the positive exponents. While we're in that mindset, we're going to go ahead and do the next table as well. So doing number 2, 1/4 to the blank. Well, I'm going to start with 0 again, and then 1/4 to the 1, and then so forth and so forth. 1/4 to the 0, anything to the 0 is 1. 1/4 to the 1 is 1/4. So we've got 1 and 1/4. When you square 1/4, you'll square the 1, square the 4, so you'll get 1 over 16. Cube 1/4, so 1 over 4 times 4 times 4, so 1 over 64. And then 4 to the 4th, may not know this one mental math, but it's 256, so 1 over 256. Therefore, when you take 1/4 to the negative 1, the exponent rule says flip your fraction, 4 over 1, and raise it to the positive 1. So 4 over 1, which is 4, raised to the 1 is going to give you 4. And then negative 2 will flip the fraction and square that 4, so 16. And again, you're seeing the same numbers, at least similar numbers, as the denominators from before. 1/4 to the negative 3 would be 4 cubed, and 1/4 to the negative 4 would be 4 to the negative 4 to the 4. That'd be 256. So that's the mental math part, and the non-calculator part to find the ordered pairs to graph. Now we're going to count by 3s in the first problem. That will fit the points best on the y-axis. And we'll count by 4s on the y-axis, because that will fit the y values of number 2 best. So we're going to do this kind of quickly, so if you need to pause it, rewind it. But when you're counting by 3s on the y-axis and 1s on the x-axis, it's a little bit different. So I'm going to start with graphing 1, 3. Right 1 up 3 would be literally right 1 up 3, counting by 3s. Right 2 up 9, so right 2 up 3, 6, 9. Right 3 up 27, so right 1, 2, 3 up 3, 6, 9, 12, 15, 18, 21, 24, 27, and that's the last one that's probably going to fit. So now I'm going to go the other direction. Graphing 0, 1 is kind of like graphing the decimal 1/3 when you're counting by 3s, so 0, 1. Negative 1, 1/3, that'd be left 1 up a little, left 1 up a little. Negative 2, 1/9, left 2 up a little. Your pencil lead's probably thicker than 1/9. So at this point, we're just graphing decimals that are really close to the x-axis. Negative 3, 1 over 27, left 3 and up a little. Negative 4 and up a little, and you start to see, okay, this pattern's going to continue forever. So we connect the dots to represent all the decimal values for x that we haven't plugged in. And we have a representation of y equals 3 to the x. Is it growth or decay? Well, you read a graph like you read a book. From left to right, it's going up, so it is growth. Domain, we could have plugged in anything we wanted to for x, so all real numbers. It goes left and right forever. Range, It goes up forever, but it does not go down forever. Notice those fractions, 1 over 9, 1 over 3, 1 over 9, 1 over 27, 1 over 81. They will always be 1 over something. So it's never going to get to 0, meaning your y value will never be 0, but it's going to be bigger than 0. So your range is y is greater than 0. Number 2, I'm going to graph it a little faster, counting by 4s on the x-axis. So -1, 4, left 1, up 1. -2, 16, so left 2, up 4, 8, 12, 16. Left 3, up 64, not going to fit. So go back to graphing 0, 1, and then the decimals. 0, 1 would be like graphing the fraction 1/4, so up a fourth. Graphing 1 1/4, right 1, up a little, almost on the x-axis. 2, 1 over 16, so right 2 and up a little. 3, 1 over 64, right 3, up a little. And again, you start to see that pattern where your decimal points get really close to the x-axis but never actually get there. And then we'll take this point, connecting them to represent all the decimals that we didn't plug in for x. And the next point, -364, we're going to kind of send this picture up and to the left slightly to -364. All right, so we have the visual representation. Is it growth or is it decay? From left to right, it's going down, so it's decaying. The domain again is all real numbers, and the range again is greater than 0. Those decimals will never get, those fractions will never get to 0, although they're getting closer and closer to 0. All right, the next part kind of gets a little bit weird, if you will, because we're going to start messing with the input and the output. And the input of an exponential is the exponent itself. So we're going to now mess with that input by subtracting 1 here in the input. So I want you to look at what's highlighted, box -1, and kind of compare it to the point 481. Because if you can make this say 3 to the 4th, you will get the answer 81. So in this box, I'd want to put a 5. 5 minus 1 would turn into 3 to the 4th, meaning if you put 5 in for x, you will get 3 to the 4th, you'll get 81. If, let's see, keep this color coordinated here. If we start thinking about the next input, kind of hard to erase a box here, but we'll put it back. Trying to make 327 happen. 3 cubed. To make 3 cubed happen, we'd have to put in an x value of 4. 4 minus 1 turns into 3 cubed, so we'll have x value 4 that gives us the answer 3 cubed that gives us 27. And by now you might start to notice a pattern. And if you'll stare at 481 and 581, you'll probably recognize that pattern. 481 has now moved to 581. 327 has now moved to 427. If you think about plotting those points, 481 to 581, 327 to 427, they are moving right 1. So essentially, subtracting this 1 to your input, moves the picture right 1. So we can move every point right 1. So the 0.29 will now be 3, 9. The 0.13 will now be right 1. It will be 2, 3, and so forth. At this point, you're pretty much going to copy these values, but you've conceptually figured out what you're doing to shift all of the points right 1. So copying these y values, 1/3, 1/9, 1 over 27, and 1 over 81. So we're not even going to mess with graphing this. It's just going to move the picture right 1. We'll talk about growth, decay, domain, range in a second. Now let's talk about number 4, because number 4 changes the output. It puts a +2 after the exponent. Remember, the exponential, the input is the exponent. So the +2 in number 4 is after the exponent, meaning you're going to make this shift after you've put the input in. All right, so it's a little confusing, but let's start with -4. We're going to put the same input in that we did in number 2. We put in -4. So that represents 1/4 to the -4, also known as 256. We already know that answer, so 256. And then according to the plus 2, we're supposed to add 2 to that. So 256 plus 2, 258. So inputting -4 will spit out 256 from the exponent, but then the plus 2 after that says, all right, take your 256 and add 2, so 258. We'll do one more manually, and then we'll kind of talk about the pattern and probably just copy points from there. The next input was -3, so putting in 1/4 to the -3 plus 2. According to the chart above, -3 gives you 64. The exponent -3, so 1/4 to the -3 is 64. Add 2, so we get 66. And by now you can probably tell, okay, I just need to put in the same numbers for x, doesn't change the input, but then add 2 to all the output, meaning that plus 2 adds 2 to your y values, the output. So we'll just kind of copy from here. 16 changes to plus 2 to 18, 4 changes to 6, 1 to 3, and now I'll switch to decimals for the corresponding y values for the rest of the table because it's going to illustrate better how this affects the range. So the decimal, when you take 1/4 and add 2, you get 2.25. When you take 2 and add 1/16, 2 plus 1/16, you get the decimal 2.0625. 2.0625. When you take 2 and add the decimal, when you take 2 and add the fraction 1/64, you get the decimal 2.0152. So about 2.0152. And then the last one, adding 2. If I can get this to work, there we go, 2. Well, being contrary here, there we go. Now clear that. Now let's try 2 plus 1/256. 2.004, about 2.004. All right, I'm going to graph this one very quickly so you can kind of see counting by, I'm going to still count by 4s like I did in number 2. Count by 4s, so 0, 3, about right there. -1, 6, so left 1, up 4, 5, 6, about right there. -2, 18, so left 2, up 4, 8, 12, 16, then a little more. And then the next point won't fit, so we'll send it to the point -3, 66. Now the decimals is where we start to understand how adding 2 affects the range. When I graph the point 1, 2.25, it'd be right 1 and then at 2.25. Then 2, 2.06, right 2 and at 2.06. Right 3 and up 2.01. All right, what are these decimals? 4, 2.004. What are these decimals getting closer and closer to? They're getting closer and closer to y equals 2, meaning you have a range that has now been shifted up 2 spots. It was at y is greater than 0. Now it's y is greater than 2. Your domain is still anything you want to plug in, and it is still decay. All right, let's finish this off with number 3. Growth, decay, domain, and range. This problem, when you've shifted all the points right 1, will still have a range looking at these decimals greater than 0. You'll still put in every point that we did before, which was all real numbers. And if it shifted it right 1, it's going to be all real numbers plus 1, which is like the concept of infinity. When you add 1 to everything, you still have everything. So the domain is still all real numbers, and it is still growth. All right, this is just for mainly the calculus-bound students because we're not going to do a whole lot with vertical and horizontal asymptotes, but the number that these fractions were getting closer and closer to but will never reach is called a horizontal asymptote. Like in number 4, those numbers kept getting closer and closer to 2. So if you drew a horizontal line at y equals 2, I'll do my best to draw one at y equals 2. I have to grab it and shift it up a little bit, if it will let me. There we go. As close as I'm going to get. That's y equals 2. That's called a horizontal asymptote, meaning that graph will get closer and closer and closer to y equals 2 as x moves towards infinity, but it will never get there. If you look back up at the first two problems, the horizontal asymptote is the x-axis, also known as y equals 0. So it's the horizontal line that gets closer and closer to, but will never actually get to. Again, not much use in Algebra 2, but going to come up in pre-calc/calculus down. So that's target 3 in about 15 minutes. Not too bad.